Now you look at table 9.8. Different chemical compounds that you can find in a clinical setting. Chlorine bleach. Chlorine bleach works great. Bleach water works great as long as you have the right concentration, as long as you're using it for the correct number of minutes. So you go in and you have bleach water, you wipe something down, it's decontaminated. The problem is we're not using it the correct concentrations, we're not going for enough time. Look at the time. Different concentrations, 50 seconds to 30 minutes. That bleach, that chlorine, whatever it's in, bleach, I keep saying bleach, chlorine, bleach, but chlorine can be in other disinfectants. The amount of time, it's not a spray and wipe, it's a spray and let set. Ethyl alcohol, you mentioned this in an earlier lecture for this chapter. You spray it, and then you're supposed to walk away. Because look at it. You're in a lab. You'll see this in microbiology labs. They'll have a water bottle or a spray bottle of 70% ethanol. They'll spray it. The thing is, look at the time, 70%, which is, what they dictate we use it at. 10 minutes to kill Staphylococcus aureus, 10 minutes to kill, damage poliovirus, 2 minutes for Escherichia coli. So a lot of times you'll see students, they'll come in, they'll spray, and then they'll immediately wipe. All they've done is they've just removed liquid to the paper, and any microbes that were floating in the liquid are now on the paper, but anything stuck to the countertop, still there, still viable. Hydrogen peroxide, love that stuff. Every little kid loves that stuff, especially you got a cup, pour it in, watch it bubble. 3%, that's what you buy it at the store. Within seconds, it's already damaging. It's already doing its thing. Ethylene oxide gas is what they use in clinical settings if they think there's a contamination problem, a surgical room or recovery rooms or in the hospital rooms. There's some sort of a fungus outbreak, an MRSA outbreak, things like that. They'll seal off the rooms and they'll pump in ethylene oxide gas. But look at it. Different concentrations can work within a few minutes. Other concentrations, 10,000 milligrams per liter in the air, it's going to take over 24 hours. So you spray in the gas, you pump in the gas, and then you walk away for a day. Germicidal categories. Germicidal, anything cidal means killer. So germicidal kills germs. Everything from the halogens, chlorine, iodine, oxidizing agents like hydrogen peroxide, the different aldehydes, things like that you see here in table 9.9. Whatever agent you're using, whatever class of agent you're using, are going to have different targets. You look at iodine. Iodine damages all endospores, all bacterial cells, all everything. Its mode of action is to get in and interfere with different metabolic functions. Gets in, strips off. Oxidizing agents like hydrogen peroxide damages pretty much all things, endospores, bacterial cells. Gets in, and the superoxide radicals strip off hydrogens off of anything and everything, proteins, DNA. So different chemical agents going to have different types of cells they can inhibit or kill, and are going to have different modes of action. You go and you look here at continued. for table 9.9. Different phenol, chlorhexide, alcohol, detergents, heavy metals. That's one of the things we're finding out. Heavy metals, copper, zinc, molecular copper, molecular zinc, has antimicrobial properties, antibacterial properties. And then lastly, you look here at some of the common household detergents or household cleaners that have been readily available, readily used, probably in most American houses. Lysol sanitizing wipes, Clorox disinfecting wipes, especially nowadays with the COVID. We see that there's a run on these. Everybody's using these. Mildew removers, disinfecting sprays. All of these have different chemical agents in them. These are, the compound that's going to be doing the damage. And when it comes down to it, they're going to have different levels of efficacy, different levels of what microbes they can damage, which ones they can kill, different levels of, how many of the microbes present, 99.9%, 99.5%, 85%, things like that. One of the things we also have to take into account is how long does this stuff have to sit there? You go and you wipe. Well, just because you wiped with Lysol or Clorox sanitizer and disinfecting wipe, did you actually sanitize? Did you actually disinfect? Because you wiped and it dried near instantly. How long does that stuff have to actually be there before you start to see effect?